this is the integrated 2, I'll just call it the 913 conclusion video. My neighbor's doing some yard work, so I don't know if you can hear him. Hopefully not too bad. Anyway, when we look at this, what I really wanted to do was show you what these parabolas look like when we're in standard form, changing from factored form into, by factoring into factored form, what we can learn there, changing it back using the area model times A to standard form, completing the square, going to graphing form, seeing what we can figure out, and then using the area model times A plus K to move us back to standard form. And I just want to show you sort of the symmetry about how you move back and forth, about how this all goes together. We spent a lot of time this year on parabolas, and I think that this video sort of ties together all the little things that we've talked about. So I hope that you're able to follow along and reach out if you have questions. So let's go ahead and begin and see how this turns out. So I've already taped this entire video and my audio didn't work the first time, so I'm making it a second time. Hopefully this one goes better. So if we start with an equation in standard form, we can learn things about it just by looking at it. First of all, we know that the y-intercept, if we plug in 0 for x, we're going to get negative 30 for the y. So I know that this is going to have a y-intercept of negative 30, and I know that I can get the axis of symmetry by plugging in negative b, well my b is 4, over 2 times a, and my a is 2. So what I'm going to get is negative 4 over 4, which is of course negative 1. So I know that if I go graph this, which I did in Desmos, I can see my y-intercept and I can see my axis of symmetry. So you'll notice I have this parabola graphed. You'll notice that I have my y-intercept at negative 30, and you'll notice that I have my axis of symmetry at x equals negative 1. So just as I suspected when we went ahead and did that. Now, what if I want to change this from standard form over into factored form? Well, I would need to do factoring, which we've done a million times this year, so hopefully you guys recall this. I could use the quadratic formula, or I could use the diamond. And on this one, I made a nice simple one where the diamond's going to work. But remember, if the diamond doesn't work, you do have options. So the first thing I'm going to do is I'm going to factor a 2 out. I can take a 2 from a 2, a 4, and a 30, so I'm going to factor that out and simplify it. And you'll notice at this point, I'm just going to take this and put it on the diamond. So I have a times c is negative 15. I apologize, by the way, if you can hear my neighbor. I might have to recut this video again if the sound is too loud in the background. And then I have ax. Well, this is just 1x, so I'm going to multiply to 15 and add, to negative 15 and add to 2, so that would be 5 and negative 3. 5 times negative 3 is negative 15. 5 minus 3 is 2. So I have the equation y equals 2, parenthesis x plus 5, x minus 3. So that's going to be my factored equation. And when I have it factored, I can immediately tell what my x-intercepts are. If I plug negative 5 in there, that will give me one of my x-intercepts because that will turn it into 0. And the other one is 3. If I plug 3 in, that will turn this into 0, and multiplying by 0 will give me 0. So I have my x-intercepts. The other thing, by looking at this a, is 2. So it's positive. So I know that my parabola is going to open up. And I also know that it's going to be steep because it is above 1. By the way, I want to point out, I don't really talk about a over here, but I could have just as easily mentioned an a. This a is 2, so I know it's positive and I know it's steep. But I don't really, for whatever reason, focus on that too much in standard form. I guess I feel like there's already enough going on over there anyways. I don't know. So long story short, I'm gonna plug this into Desmos, and I want to point out a couple things. First thing I want to point out is that this equation and this equation are the same. It'll give the same parabola. They just look different. Even though these look totally different, they're exactly the same equation. The second thing I want to point out is you will see that the x-intercepts are negative 5, 0, and 3, 0, and then it does open it up and is steep. So let's go ahead and graph this one. So you'll notice that this parabola, the green one, is the same as the red one. You will notice that it has the x-intercepts of negative 5, 0, and positive 3, 0 like we talked about, that it does open up, and that it is steep. So all those things that we had discussed back over here. Now the question is, what if you get a problem that's in factored form and you need to put it in standard form? Well, what we can do is we can multiply the area model by a. So this part of it, this x plus 5, x minus 3, I can just go ahead and turn into an area model. And I'm going to get x squared there. I'm going to get negative 3x here. I'm going to get positive 5x here and negative 15. So I get x squared, negative 3x plus 5x is 2x minus 15. And at this point, you should be saying, well, this equation isn't the same as this equation. But you'll notice I haven't multiplied it by this a yet. I've only dealt with this part of the equation. I still need to introduce this multiplying by 2. So I'll distribute that. I'll get 2x squared plus 4x minus 30. And you can see I'm right back to where I was with the standard form. So that's the a times area model to go from factored form into standard form. Now that I'm in standard form again, I can complete the square and go to the graphing form. And you'll recall that I have this whole worksheet on how to complete the square. I'm not going to flip over to that and use it here. I'm just going to go through the steps here, but I hope you're able to follow. So you might want to get that sheet handy though, so you can see how I'm going through those steps. First thing I want to do is get rid of the number I don't want. I don't want that negative 30, so I'm going to add 30 to both sides to get it out of the way here. So I'm going to get 30 equals 2x squared plus 4x. At this point, that negative 30 plus 30 goes away. I'm going to factor out what I can here. Can I take a number out of 2 and 4? Yeah, I can take 2 out of both of those. So I'm going to factor a 2 out of both of these. And I'm going to be left with this. The reason why I did that is now that I can go ahead and add the perfect number in here. You'll notice that the perfect number again is b over 2 squared. Well, my b term is 2. So 2 divided by 2 is 1, and 1 squared is 1. So I'm going to add 1 to this parenthesis. But again, everything in this parenthesis is times 2, right? 2x squared, 2 times 2 is 4, so 2 times 1 is 2. So I'm really adding 2. And that's going to bring me 32 equals 2 times x squared plus 2x plus 1. Now the reason why I wrote this and put the perfect number in is so that I could make a perfect square. And I can complete the square now. So this x squared is going to go here. Half of this 2x is going to go here, and half will go here. So x plus x is 2x, and then I have a 1. So again, this x squared plus 2x plus 1 is right here. X squared plus 2x plus 1. But I don't want to write it as a sum. I want to write it as a product. So x times x is x squared. X times 1 is x. X times 1 is x. And 1 times 1 is 1. So you'll notice what I've done is I've rewritten this x squared plus 2x plus 1. Instead of using the sum, I'm using the product. So it would be rewritten like this as a perfect square. And finally, what I need to do is I need to move this 32 back over to get everything back on the same side. And I'll just go ahead and write the answer down here. So I get 0 equals 2 x plus 1 squared minus 32. So this is going to be the graphing form. And the nice thing about graphing form, like we said, is it's really easy to get the vertex. I know that the x is going to be whatever makes this 0, so negative 1. And if this is 0, y is going to equal negative 32. So there's my vertex of negative 1, negative 32. And we'd already discussed it over here. And like I said, you can get it here from this a, but it is positive 2. So it does open up, and it is steep. So what I want you to see when we run back over to Desmos is that I'm going to have this equation. And again, this equation will be the exact same as this equation and the exact same as this equation. They're all going to give the same parabola. They just look different. And the reason that they look different is because they provide different pieces of the parabola. So we'll see that the vertex is indeed negative 1, negative 32. So again, I will go ahead and put this parabola in. It looks the same as this parabola, and it looks the same as this parabola. I'm not quite sure why it's not like changing colors. Normally it like, there we go, it kind of puts the colors over it. And again, that negative 1, negative 32 is our vertex. So the last piece of this is, well, what if we're given something in graphing form and we want to turn it back into standard form? Well, what we do is we'll multiply the area model by A, and then we will add K to it. So I'm going to start with this part. Again, it's order of operations, parentheses, exponents, before multiplying, before addition and subtraction. So I'm going to have my x plus 1 squared. I mean, we already know what it looks like over here, but I'll do it again. So I have my x plus 1 squared. That's going to give me x squared, x, and 1. So I'll rewrite my product as a sum now, the exact opposite of what I did over here. So I have x squared plus 2x plus 1. But again, I haven't dealt with this a, and I haven't dealt with this k. So I've just turned this x plus 1 into x squared plus 2x plus 1. I will distribute the a, or the 2, to get 2x squared plus 4x plus 2 minus 32. And then the last thing I'll do is I'll deal with that k. So I'll combine those, and I'm going to get y equals 2x squared plus 4x minus 30. And you'll see I'm right back where I was in standard form. So I know there's a ton going on here, guys. This is not meant to be like a 15-minute lesson. This is meant to be like a weeks-long lesson, and we've been dealing with this stuff all year. So if you're in standard form, you can get, just to tie it up again, these equations are all the same. They all give the same parabola. If you're in standard form, you can get the y-intercept by looking at it, and you can get your axis of symmetry very easily. You can factor to put it into factored form. When it's in factored form, you can easily get the x-intercepts, and you can easily tell if it opens up or down, and if it's steep or if it's flat. If you're in factored form, you can multiply the area model by A to put you back into standard form. From standard form, you can complete the square. And when you're in, to get to graphing form. When you're in graphing form, you can easily get the vertex and see with the A if it opens up or if it's flat or whatever. And then again, if you're in graphing form, you can multiply the area model by A and add that K. Again, multiply the area model by A and add that K to get you right back to standard form. I hope this makes sense. I hope this helps. Please reach out if you guys have any questions, and I will talk to you later.